Hello everyone, let us discuss about Markov chains. The contents we are discussing today is introduction part, properties of Markov chains, types of Markov chains, probability vectors and real-time applications. Let us discuss about introduction. A. Markov, 14th June 1856 to 20th June 1922, was a Russian mathematician best known for his work on stochastic processes. Its definition is a Markov chain or Markov process is a stochastic model describing a sequence of possible events in which the probability of each event depends only on the state attained in the previous event. Properties of Markov chains. First one is reducibility, aperiodic, transient and recurrent states. Types of Markov chains. First one is discrete time Markov chain or discrete time discrete state Markov process. Second one is continuous time Markov chain or continuous time discrete state Markov process. Third one is discrete time Markov process or discrete time continuous state Markov process. Probability vector. A probability vector is a vector with non-negative entries that add up to 1. A stochastic matrix is a square matrix whose columns are probability vectors. A Markov chain of vector in Rn describes a system or a sequence of experiments. Xk is called state vector. Let us discuss about first application. The case supposes that there are two types of weather in a particular area, that is sunny and cloudy. A news channel wants to broadcast their prediction about the next week's weather. The news channel hires a weather forecast company to find out the next week's weather and also for the following weeks. Currently there is sunny weather in that area. The probability of the weather staying sunny the following week is 80%. Probability of the weather changing from sunny to cloudy over a week is 20%. Probability of the weather staying cloudy the following week is 70%. Probability of the weather changing from cloudy to sunny over a week is 30%. Although the weather is predicted to be sunny, the whole week one cannot be sure about the next week without making some transition calculation. The below matrix is to be followed. Current state into transition matrix equal to final state. Let S denote sunny and C denotes cloudy. Here is the matrix. It can be seen that there is 80% chance that the next whole week will also be sunny, but there is 20% chance that the weather might change to cloudy next week. This calculation is called Markov chain. If the transition matrix doesn't change with time, one can also predict the weather for further weeks using the same equation. Calculation for the weather forecast in the 2 weeks time is given as below. Second application, next word prediction. The Markov chain helps to build a system that when given an incomplete sentence, the system tries to predict the next word in the sentence. Since every word has a state and predicts the next word based on the previous states. To understand that, let's take a simple example. Consider 3 simple sentences. I like physics, I love cycling, I like books. All of the unique words from the preceding sentences, namely I, like, love, physics, cycling and books, might construct a various states. The probability distribution is concerned with assessing the likelihood of transitioning from one state to another. In our instance, from one word to another, the preceding example shows that the first word in our situation always begins with the word I. As a result, there is 100% probability that the first word of the phrase will be I. We must select between the terms like and love for the second state. The probability distribution now is all about calculating the likelihood that the following word will be like or love if the preceding word is I. In our example, the word like comes in 2 of 3 phrases after I, but the word love appears just once. As a result, there is a 67% probability that like will prevail after I and 33% probability that love will succeed after I. Similarly, there is 50% probability that physics and books would succeed like, and the word love is always followed by the word cycling. Third one is PageRank used by Google. Page and Brin created the algorithm which was dubbed PageRank after Larry Page. PageRank is one of the strategies Google uses to assess the relevance or value of a page. To use the PageRank algorithm, we assume the web to be directed graph, with web pages acting as nodes and hyperlinks acting as edges. PageRank assigns a value to a page depending on the number of backlinks referring to it. A page that is connected to many other pages earns a high rank. To calculate a page score, keep in mind that the surfer can choose any page. However, they do not always choose the page in the same order. Most of the time, a surfer will follow links from the page sequentially. For example, the page A, the surfer will follow the outbound connection and then go to one of the page A's neighbors. However, this is not always. A lesser but significant proportion of the time, the surfer will abandon the current page and select a random page from the web to teleport to. To account for such a scenario, page and bin devise the damping factor which qualifies the likelihood that the surfer abandons the current page and teleports to a new one, because the user can teleport to any web page. Each page has a chance of being picked by the nth page. This is how I shown how the links and pages are selected. Thank you for watching.